Welcome to the Unit 8 review for 6th grade math. Here we go. All right, so your first learning target says, I can use variables in various contexts. Match the situation to the algebraic expression that best fits the sentence. So way back in the beginning of this unit, we learned that certain words indicate that we should add, subtract, multiply, or divide, and we came up with a big list of what those would be. But there were a couple really interesting special ones, and that would be things like less than, or we could say more than, but that doesn't really change anything, or subtracted from, we could say, would be another one that would be what we would call a turnaround word. Less than is almost always the most used turnaround word. So what a turnaround word means is that when it's a minus problem, you have to be extra careful. All the other ones are pretty much set how they are, but a minus problem, you have to look and make sure that you are doing the correct order. So if it says less than, or younger than, or smaller than, anything that would indicate less than, and using that word then, you're actually going to turn those numbers around. And so we're going to look and see what I mean by that. So the first one says 7 minus a number. Okay, 7 minus a number. Simple as that. That matches 7 minus n. Okay, 7 times a number. Well, 7 times a number, or 7 times a number, or when we're talking about an algebraic expression, we want to write it in algebra, which would be a number touching that letter n, 7n. Okay, so these ones aren't wrong. They're just not going to match over here because we're looking to write it algebraically. In algebra, this would be the way that we would want to write that. A number split evenly into 7 groups. Well, if we're splitting things into groups, we are dividing. So we're taking a number and we are splitting it into 7 groups. We're taking n and we're dividing it by 7. Here's that 7 less than a number. So let's put a number here. If I said 7 less than 10, what would you tell me my answer was? 3, right? So if I wrote this in the order 7 minus 10, do I get 3? I don't. So to kind of put a number in there and think about it. So whenever you have a minus, just double check. Is that the correct order? So 7 less than a number would be the number and then minus 7. Just like if we put the 10 there, it'd be the 10 minus 7 to get that answer of 3. And so the number minus 7 is this one. And a number added to 7. I'm going to take my 7 and I'm going to add that number. Oh, and I have it backwards, but addition doesn't matter what order they're in. Subtraction and division do. All right, so for this one, we're really just looking at those words and saying, what word is it indicating? Add, subtract, multiply, or divide. I suggest doing the easiest ones first, and then by process of elimination, maybe you will get the hard ones through that. Okay, next, again, we're talking about algebra. We're saying I can evaluate algebraic expressions for a given variable. So here are my given variables. I'm being told that what if A was 3, B was 4, and C was 2? Well, I would plug these numbers in where I see them. So if I say A is 3, instead of writing A, I'm going to write 3 there. And B is 4, I'm going to write a 4 there, and I'm combining them with addition. So that answer would be 7. If I have B minus C, again, I'm going to take 4, because that's what B is, minus C. So minus 2, because that's what C is, and I get 2. Now, this is where we need to know what it means when things touch. So this does not say A plus C. This doesn't say A and then C. This says A times C. You don't see the times symbol, but it is what it's indicating. So I'm going to take A, which is 3, and I'm going to multiply it times C, which is 2, and I get 6. So the most common wrong answer there would be 32. And so we're not just putting those numbers next to each other. When they're touching like that, it means they're multiplied. Same with the 3b. This doesn't just say 3b. Yes, we say 3b, but it means 3 times b, whatever b is. So 3 times 4, and that gives us 12. And the last one, we have two things going on. I have 2 times b, and then I have plus a. So we want to do these in order of operations. We'll do our 2 times b first, and then we'll add on the a. So we've got 8 plus 3 is 11. When we're solving equations, I would like to see you do this in proper form because we did take a little taste into two-step equations to see that, oh, more comes about, and we're going to go to 3 and multi-step equations. And so I want you to have a good, firm grounding on this. So what I'd like to see is I'd like you to separate the problem. I call these train tracks. I'm separating the problem, having a left side of the equal sign and a right side of the equal sign. I want you to find that variable and get rid of this excess stuff. So I'm going to get rid of the plus or the positive 4. So I'm going to subtract 4 from both sides. Because what I do to one side, I do the same thing to the other side. Think about it as a balance. So if I have a balance here, if I take something off of this side, so if I have 4 things here and an n, we'll make this little box the n. And I have 11 things over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, if I take these 4 off of this side, it's going to make this side heavy and fall down. So I've got to do the same thing in order to keep it balanced. When I do that, I'm left with 7 on this side. And this box, or whatever, we're going to call it n on this side. So what belongs where the n is? Well, n, the solution is n equals 7. And we can plug that back in and test it. 4 plus 7 equals 11. That's a true statement, so we know I did it correctly. The next one, I'm going to do the same thing. Remember, we're working on our brains not thinking the answer comes next. Instead, this kind of looks like the answer comes first, but remember, it's not an answer. It's just saying one side is the same as the other side. So 12 is the same as m take away 9. So I'm going to undo this by adding 9 to both sides. What I do to one side, I do to the other side. These 9s, when they're opposite, they can go away. We call that canceling them out. And so I have just m left on this side. Well, m is going to be equal to 21 because I just took 12 plus 9. I can check 21 minus 9. Is that the same as 12? It is. All right, here's those numbers and letters touching again. Remember, that means multiply. So to get rid of the 3, because I want to get the w by itself, I'm going to divide by 3. If I have a number on the top and the bottom of a division sign, they cancel out. It equals 1. So I've got w on the left and 24 divided by 3, which is 8 on the right. W equals 8. And if I take 3 times 8, I do get 24. Check. Okay, and the last one, this looks so tricky because it looks like a fraction. But remember, fractions are just division problems. So this could say c sevenths, or it could be c divided by 7. And I want you to think about this in whatever way is the easiest. And in this case, thinking of this as c divided by 7 is the easiest way for us to think about this, because I know what to do. If it's just showing a fraction, I don't really know what to do to get rid of the bottom of a fraction. So to get rid of divided by 7, I'm going to multiply times 7. What I do to one side, I do to the other side. Having opposite operations, divided by times 7, that cancels out, and I have c left on the left side. 10 times 7 is 70. I can check, plug that 70 up top, 70 divided by 7. Does that equal 10? It does. Now, I know that you can guess and correctly probably guess on all of these, but I would like to see on these your work shown. So I would like to see what is the one step you did to solve these, because remember, the point isn't that you can figure them out so much as that you are on your way to figuring out harder problems by using a method. All right, the last learning target, I can create and graph functions and equations. So here you can see I've got a table. It's got minutes and rotations. And so if I called my minutes, let's call that X, and my rotations Y. I want to know, ooh, look at, actually I wrote M and R down here, M, R. I want to know, what did I do to the M to make it into the R? Okay, what is my rule to get from one side of the table to the other side of the table? I noticed that for the first one, 3 to 12, I could multiply times 4, or I could add 9. So those are my two options. I could multiply times 4, or I could add 9. I'm going to check this next one. If I multiply times 4, does it work? Yes. If I add 9, does it work? No. So I'm going to check the next one and see if multiplying by 4 works for all of them. It does, it does, it does. Okay, so I know my rule is times 4. But if I'm trying to do this algebraically, I know that if I just said the minutes times 4, that is correct. That would equal the rotations. But is there a more algebraic way of writing that? And it would be to write it as 4m equals r, which is this one. Now, if you had this, clearly it's not adding, and all of these are adding. So we could just get rid of all of them and see that we are doing a multiplying relationship. When there's a relationship that multiplies, we call it multiplicative, which we will see on the next slide. All right, the next one shows us a graph. We see the number of weeks and the total allowance. So as the number of weeks goes up, the amount of allowance that you have gotten is also going up. I see that on 1, it goes over here somewhere between 0 and 6, so I call that 3, and then 2 and 6, 3 and 9, okay, 4 and 12, 5 and 15. Okay, we can kind of fill in those missing blanks. This says circle the equation that best matches the graph shown. So we're going to call W weeks and A allowance. So when my W is, let's say, 2, the number of weeks is 2, my allowance is 6. So let's try plugging those in. If I plug in a 2 for weeks, 3 times 2, oh, look at that, I get 6. Okay, so the first one works. If the first one works, it doesn't mean it's the only one that works, so let's go ahead and check the other ones. 2 plus 3, that does not equal 6, so it's not B. We can plug in 3 here, 2, I made a mistake here, 2 plus 2, but that still doesn't equal 6. Okay, 6 times 2 does not equal 6, it equals 12. So I should say doesn't equal 6, and then I've got 2 plus 6, that does not equal 6. So this one is my only option. Another thing that you can do is you can say, okay, how is this increasing? If this was on a table, how do I get from 2 to 6? I could multiply times 3, or I could add 4. How do I get from 4 to 12? Well, I could multiply by 3, or I could add 8. Which one do they have in common? Multiplying times 3. So that's going to be my rule. On this page, we tried some of these in class where we are looking at the one and only thing that's given to us. In this case, it is our graph. So we're going to look at our graph, and when I look at this point, it's kind of tricky to know exactly where it lands over here. So I'm going to go ahead and go to 2 and 4 and 6. And I see that I've got 2, 4, and 6 over here, and I'm going to list out what the other value is. So this is 2 hours, and it is 150 miles. So I'm going to plug that in over here, 150. Then I've got 4 hours and 300 miles. And I've got 6 hours and 450 miles. Okay, if I went over to this one, I could probably figure out where it's at. But instead of just guessing, could I figure out how many miles there would be in one by looking at the relationship here? So if I look at the relationship, how did I get from 2 to 150? I could add 148, or I could multiply times 75. So if I'm adding 148 148, if I tried adding 148 to 4, that's not going to give me 300. So it is definitely a multiplicative relationship where I am timesing by 75 to get that. So over here, my equation, if I'm using y's and x's, remember this is always x, this is y. I'm going to say y is equal to 75x. Okay, so here's our situation. The barge is traveling down the river at a speed of, yikes, 75 miles per hour. That's going extremely fast. Not every math problem is super realistic like this one. Barges normally don't travel that quickly. Okay, so at the bottom here it says, is the relationship above multiplicative or additive? That's basically saying, look at your equation. Did you multiply or did you add in your equation? In other words, what is the rule to get from here to here? Did I multiply or did I add? If I multiplied, I'm going to pick multiplicative. If I added, I'm going to pick additive. Remember what we talked about in class, if you multiply or you add, right? But also that all multiplication can be written, or sorry, all division can be written as a multiplication of a fraction. So division is multiplicative and all additives could be subtraction or as well, or subtraction could be addition by talking about it as like a negative. So adding or subtracting is additive and multiplying or dividing is multiplicative. On your test, you're going to have a two-step equation. We did cover these in class, but we did it really briefly. It's going to give you a bonus point if you can get this one correctly. So what I'm looking to see is I'm looking to see you show your work. I want to see that you separated the two sides. The first thing we always get rid of is either plus or minus. Remember, we're going in opposite of the order of operations. So the order of operations says I'm going to do parentheses, then I'm going to do exponents, then I'm going to multiply and divide, then I'm going to add and subtract. And so if I want to undo this problem, I want to go backwards in the order of operations. So I'm going to undo plus or minus first. So I'm going to undo the plus 9 by doing minus 9 to both sides. Okay? Then I've got 5x is equal to 65. Okay? So then I want to take my 5 and I want to divide by, I'm going to take my 5x. And now I just have a one-step equation. So I'm going to divide by 5. I'm going to divide by 5. And x is equal to 13. Now, unfortunately, on your practice, this is not a bonus point, but if you can get it correct on the test, it does count for 1 extra point on your test. Good luck in your studying. Bring your questions tomorrow.